Right, now let's talk about coefficient of friction and inclined plane worksheet. Lucky for you, we're not going to talk about inclined plane on the quiz here. I will make another video on that later. Don't want you to have to worry about that right now. So we've got 1 through 5 on the front. Let's skip 6, 7, and 8. Okay, so just skip page 2 for now. We will come back to it. All right. So basically this whole entire thing is going to be about the coefficient of friction, okay? So, question 1. A hockey puck has a coefficient of friction of mu, k, so that means it's moving, has a coefficient of friction of 0.10. If the puck feels a normal force of 5 newtons, what is the frictional force that acts on the puck? Well, this is just an easy plug and chug. Our force of friction equals our mu times our normal force. We know that our mu is 0.10. We know that our normal force is 5 newtons. So 0.1 times 5 gives us 0.5 newtons. There you go. It didn't give us a direction. All we need is the number there. All right, number 2. Number 2 says, suppose a 10 Newton force that is applied to the side of a 4 kilogram block that is sitting on a table. The block experiences a frictional force against the force that is applied. So I'm going to draw my free body diagram over here. So we have a block that is on a table. Should I draw little legs? You know it's a table. Oh, that's beautiful. And we know that the mass of this block equals 4 kilograms. We also know that there's a 10 Newton force applied. Just for the sake of it, I'm going to put it to the right. So my force applied equals 10 newtons. I also know that since this object has mass, it also has weight. So the weight of this object, to find the weight of my object, I do mass times acceleration due to gravity. So my weight is this 4 times acceleration due to gravity, which is 9.8. So 4 times 9.8 equals 39.2 newtons. Ah, look at this. Part B says, what is the weight? 39.2 newtons. And I'm going to say down, just so I can show the vector for it. We said that the block is sitting on the table, therefore the forces are balanced. My weight that is pushing down is equal and opposite to the normal force pushing up. That's the table supporting the block. So my next question is, what's the normal force? It's the same thing, 39.2 newtons, except this time it's facing up. Okay. One more thing, it says the block experiences a frictional force. So here's friction going this way. All right, and we can't calculate friction yet because we need mu. But look at part D. If the coefficient of friction is is mu k equals 0.20, what is the frictional force? We're going to use our formula that we used in question number 1. We're going to say our frictional force equals our mu times our normal force. We know that mu now is 0.20. We know our normal force from part C, which is 39.2. So 39.2 times 0.2. We end up with a frictional force of 7.84 newtons. All right, so I could put that in here. Let me erase it and draw it again. My frictional force equals 7.84 newtons. Okay, that's drawn in there. All right, part E says, what is the net force on the block? So remember, net force is where we compare our ups and downs and lefts and rights. We know that weight and normal force are equal and opposite, so we don't really need to worry about our up and down, so let's just worry about our left and right. So left is 7.84, right is 10, so what's the difference between those? 10 minus 7.84 is 2.16 newtons. That's our overall force, the whole entire force acting on the object. In what direction is it going? It's going to the right. Okay, next one. What's the acceleration of the block from the net force? We use our classic force problem, that is F equals m times A. And this time, A is not due to gravity, it's due to this box being pushed to the right. So what did I say my net force just was? 2.16 newtons. What's my mass? We got it in the problem. That's 4 kilograms. Times our acceleration. So how do I get acceleration by itself? I divide both sides by 4. Sorry, that's hard to see. But 2.16 divided by 4, that gives me an acceleration of 0.54 meters per second squared. What direction? To the right. All right, part 3 actually goes with, question 3 actually goes with question 2. So it says, for the block in problem 2, what would be the minimum value of the coefficient of static friction, or mu, in order for the block to remain motionless? So if it's going to remain motionless, it means that it has no acceleration. And when we have no acceleration, so I'm going to say here, let's see here. Boop, boop, boop. Acceleration equals 0 meters per second squared. And when our acceleration is 0, that means our F net is 0. And so what does it mean for our drawing? It means that everything has to be totally balanced. The top and the bottom are, but the left and the right aren't. But we are not changing how much applied force we're putting on it. We're only changing how much coefficient of friction we have. So therefore we're changing what's our frictional force. So we need our frictional force to equal our applied force. So now I'm going to say my frictional force equals my mu times my normal force. Brain is still not all the way there. All right, so now I want my frictional force to equal to 10 newtons. I don't know what my mu is, but I still know my normal force from before, and that's 39.2. Okay, so how do I get mu by itself? Divide both sides by 39.2. So let's see, where can I write this? So for here, mu equals 10 divided by 39.2. And I end up with a mu of mu equals 0.255. Okay, that's my answer. Remember, mu has no units to it. All right, number 4 is kind of an extension of 3. So it says a block weighing 300 newtons moves at a constant speed over a horizontal surface by a force of 50 newtons applied parallel to the surface. So the first thing is constant speed. What does constant speed mean? Constant speed means there's no acceleration. All right, and I said if there's no acceleration, my net force equals 0. And what happens if my F net is 0? It means my up and my down is balanced and my left and my right are balanced. So what does it mean? It means all forces are balanced. So how would we draw that? It says draw a force diagram. So here's my block. It's on a horizontal surface. All of them are balanced. It told me my weight is 300 newtons. Therefore, equal and opposite would be my normal force. It says the applied force is 50 newtons. Once again, we'll go to the right. And And so equal and opposite has to be my frictional force, which is also 50 newtons. This is what it looks like. Okay, so it's moving at a constant speed. So when I draw this and everything is perfectly balanced, this could either be stopped or it could be moving at a constant speed. You don't know. You have to have more information than that. Okay? All right, so part C says, what is the coefficient of kinetic friction? So we have to have our frictional force equals our kinetic friction times our normal force. I know that my frictional force is 50. I don't know my mu, I want to find it, but I do know that my normal force is 300 newtons. All right, so how do I solve this? Got to divide by 300 to get mu by itself. And 50 divided by 300 gives me a, oops, I did that backwards. Gives me a mu equal to 0.167, we'll say. Okay, there is our coefficient of friction. Next question says, what is the mass of the block? I know that mass is equal to weight divided by our acceleration due to gravity. So let's just write this here. My weight equals my mass times my acceleration due to gravity. I know that my weight is 300 newtons. Mass is what I'm looking for. Acceleration due to gravity, that's just normal gravity, 9.8. How do I solve? I divide each side by 9.8 to get mass by itself. So 300, just click the wrong thing here. So 300 divided by 9.8, I end up with a mass of 30.6 kilograms. Mass is in kilograms. All right, part E says, what would the acceleration be if our mu equals 0? So if we change our mu, we're going to change our frictional force. So frictional force equals mu times our normal force. So if it was 0 times 300, I'd end up with a frictional force that equals 0 newtons. Okay, so now I know that my applied force is 50 to the right. My frictional force would be 0 to the left. So what would my net force be? That would just be 50 newtons to the right. And now I can solve for acceleration because I know that F net equals mass times acceleration. So my net force is 50. My mass, which I found here in part D, is still 30.6 times my acceleration. How do I solve for acceleration? I got to divide both sides by 30.6. All right, so 50 divided by 30.6, and I end up with an acceleration equal to 1.63 meters per second squared. Okay, that's my acceleration for part E. All right, number 5. A 100 Newton force that is applied to a side of a crate resting on the floor. The crate has a mass of 50 kilograms. If the coefficient of static friction is 0.25, is the 100 Newton force enough to make the cart accelerate? Why or why not? So yeah, as always, start with the free body diagram. That makes the most sense. So let's see here. We've got a crate. And our crate's mass is 50 kilograms. So we have to find the weight. So the weight, here's my level floor, by the way. So my weight is my mass times acceleration due to gravity. So 50 times 9.8, and I end up with a weight of 490 newtons. Okay, once again, this, like anything else, it is sitting on a level floor, therefore our normal force is equal and opposite to our weight. So here's my normal force, which also equals 490 newtons. Okay. So now it says we have 100 newtons applied to the floor. Or excuse me, applied to the crate. So my applied force equals 100 newtons. But now I want to see what my frictional force is. We got to solve for it. So my frictional force equals mu times my normal force. My mu is 0.25. My normal force is 490. So 490 times 0.25. I end up with a frictional force of 122.5 newtons. So my question says, we know that these balance normal force and gravitational force, so now we want to compare our applied force and our force of friction. We're pushing on this box with 100 newtons, but the force of friction is 122.5. So will our crate accelerate? No. And why or why not? The applied force is not greater than the frictional force. We got to overcome that frictional force in order to get it moving. All right, that's it for the first page of the coefficient of friction and inclined plane worksheet.